This is Ishan Abasi, student number BL212310006. I am here to present the oral presentation for the MSEN 6414P. Background of material. The history of material was very much old, that is, in the Stone Age, pre 2500 BC. Hard, brittle material was used to make weapons, tools, and earthenwares. Stone Age tools. One of the most advancement in the human history was to development the use of tools. These tools allows humans to become master of the environment and to learn to build and to perform important tasks that made their life easier. The first tool was made up of stone. The historians refer to period of time before written history as a Stone Age. The Bronze Age hut. The Bronze Age tools were hard and tough but quite malleable. Here are examples of Bronze Age tools. Iron Age hut. The Iron Age hut 500 BC to 1850 AD. The Iron Age tools are hard, tough, brittle, and cheap. They are made up of they were used to make sophisticated tools, bridges, ships, etc. Iron bridge in shore fire. The world first iron bridge was built over the river Severn to Coal Brookfield. Not only iron founders and industrial folks to see the wondrous bridge, but also artists and travelers. The bridge had a far-reaching impact on the local and local society and economy. The given picture was the iron bridge, first iron bridge. Old Stephen Bridge, the 19th century steel become available. This had increased strength and lower brittleness, that allow the large structures to be made. Carbon fibers used to make part of some cars. 20th century composite materials, synthetic and plastic, become available, which provide greater strength and flexibility together, which with the low density. These provide the particular useful to aircraft and civil engineering industries. Molecular machine features and high temperature superconductor nanotechnology, which enables new material to be synthesized at the molecular and atomic level. Advanced material to electronic and photovoltaic devices such as optical computing and etc. Why background of material is important? Background of any information about the material identifies and describe the history and nature of the well-defined research problem with reference to the existing nature. The background information should indicate the root of problem being studies, appropriate context of the problem is related to history, research, and practical, and its scope and content of previous studies was successfully investigate the problem. Nothing in particular where gap exists between the study important to address. Synthesis of material. There are two main methods for the synthesis of top down method and bottom up approach. Top down methods are methods have several other sub methods. Optical lithoscopy, block copolymer lithoscopy, and scanning probe lithoscopy are described in the top down method. The bottom up approach is sol gel nanofabrication, molecular self assembly, physical and chemical vapor deposition. Optical lithoscopy, there is the merits. Long-standing established micro nanofabrication tools, especially for the chip production, sufficient level of resolution at high temperature. It has some demerits. The general remarks about the in the 93 nanometer lithography infrastructure already reached a certain level of maturity in sophistication, and approach could be extended to extreme ultraviolet scope for shrink of dimension. Also, future development need to address the growing cost of the market. Here is the merit of e-beam lithoscopy and demerits, as well as general remarks. Soft and nano empiric lithoscopy. Here are describe the merit, demerits, and general remarks about the that particular method. Copolymer, block polymer lithoscopy. There are the merits, demerits, and general remarks. Scanning probe lithoscopy, merits, demerits, and general remarks. Atomic layer deposition, merits, demerits, and general remarks. Sol gel fabrication, merit, demerits, and general remarks. Molecular self assembly, merit, demerits, and general remarks. Physical chemical vapor deposition, merits, demerits, and general remarks. DNA scaffolding, merits, demerits, and general remarks. Characterization of material. Various techniques have been used to characterize the materials such as XRD, X-ray, XPS, SEM, TEM, and BET, particle analyzer. Morphological characterization. There are two main morphological characterization tools are available: scanning electron microscopy and transmission electron microscopy. Scanning electron microscopy has been used for the long time. It is used for the morphological study of materials at the nano level scale. The technique is based on electron scanning principle. It provides available information about the material at nano level scale. Wide literature is available where people use the techniques to study not only the morphological nanomaterial but also dispersion of the nanomaterial bulk and matrix is the basic principle and the technique for the transmission electron microscopy. Structure characterization. Various techniques have been used to for the structure characterization of materials: X-ray diffraction, energy dispersive X-ray, X-ray photon electroscopy, spectroscopy, infrared spectroscopy, Raman spectroscopy, Bonner, Emmett Teller, and zeta size analyzer. X-ray diffraction. X-ray is one of the most important characterization technique to reveal the structural properties of materials. Here is the detail of X-ray spectroscopy written in the slide. Energy dispersive is normally fixed and field emission electron microscopy, and TEM is widely used to about the elemental composition or rough idea of percentage weight. X-ray photoelectron spectroscopy (XPS) is considered the most sensitive technique, and it is widely used to determine the exact elemental ratio and exact bonding nature of the element and nanoparticles. It is surface sensitive technique and can be used in the depth profiling studies to know the overall composition and compositional vibrational with the depth. Infrared and Raman spectroscopy. These are the spectroscopies normally used for the studies of various materials to confirm the functional groups and the Raman peaks. Zeta sizer, zeta size analyzer. It is used for the size molecular size of molecules in a liquid medium. There are three fundamental parameters that is measured by the zeta sizer analyzer: the particle size, zeta potential, and molecular weight. Properties of materials: electronic and optical properties, magnetic properties, optical mechanical properties, and thermal properties. Electronic optical properties. The optical properties of materials are interdependent of the greater extent. For example, novel metals have size dependent optical properties. Magnetic properties are a great curiosity of investigators from an electron range of similar which include heterogeneous and homogeneous catalysis. Thermal properties. Metals have thermal conductivities higher than those of fluid and solids. Mechanical properties. This mechanical property allows researchers to look at the novel application in many important fields such as travel surface engineering, nanofabrication, nanomanufacturing. Application of materials. Application in the medications. Application in the manufacturing of material. Application in the environment. Application in the electronics. Application in the energy harvesting. Application in the mechanical industries. Application in drug medication. Nanoparticles. Nano-sized organic particles of either simple or complex nature used for the medical field. In the medical field, in it can be used in the manufacturing of materials. Application environment, application in electronics, application in energy harvesting, application in the mechanical industries. Summary. This In this presentation, I presented a detailed overview about material synthesis, characterization, physicochemical properties, and application through different characterization techniques such as SEM, TEM, XRD. It was revealed that nanoparticles have ranges nanoparticle have ranges from few nanometer to 500. While the morphology is also controlled due to their tiny size, nanoparticles have large surface area which make them suitable candidate for the various applications. Besides this, the optical properties are also dominant at that size and which increase the importance of material into photocatalytic applications. Synthetic technique can be useful to control the specific morphological size and magnetic properties of nanoparticle. Thus, the nanoparticles are useful in many applications, but still there are some health hazard concerns due to uncontrollable use and discharge to natural environment, which should be considered for make them use to nanoparticles more convenient and environmentally friendly. Here are the references, and then thank you.